Great.
Okay, great.
Perfect. All right, so I'm going to hand it over to Deirdre, who's going to be your moderator for this panel session. Oh, I don't know. Is he going, Mark? Yes, Mark, you're up there. Okay.
Yes, yeah. Thank you.
It's like herding cattle. I'm just kidding.
You got a seat for the camera.
This one.
Yeah, I can pass that. All right. Thank you for sticking around for our panel. If you don't know me, I'm Deirdre Griffin-LaHue, and I'm a soil scientist at WSU Mount Vernon, and I'm going to be moderating this panel. I'll briefly introduce our panelists. You've heard from some of them already today, but next to me is Mark Bolda from UC Cooperative Extension in California. We have Tom Forge, who you just heard from, with Agri-Canada. And then we have Kevin Berendsen with Enfield Farms and Riley Spears with Rader Farms. And then we also have Jerry Weiland with USDA-ARS in Corvallis. So we're going to kind of talk about where Tom really set us up well for the intersection of soil health and plant disease and pest disease suppression. And we've had great talks this morning so far on kind of the state of the knowledge, what's been done, what research has been done, what the biology of these organisms that are important for disease management and pest management in raspberries are. But I want to start with kind of thinking about, going forward, what are the most significant gaps in our knowledge thus far for growers to confidently manage pests and disease in red raspberry. So I'm going to first pick on the two folks we haven't heard from yet today, Riley and Kevin. So if you could talk a little bit about, just what are your biggest questions for disease and pest management in red raspberry?
Are we on? Yeah. So I guess for me, as like a commercial or conventional raspberry blueberry grower, it's how do we find that roadmap kind of from getting away from the practices that we know negatively impact soil health and kind of implement these practices that we know that benefit soil health, such as, no-till, cover crops. As a conventional grower, we kind of rely on these synthetic fertilizers, pesticides, things like that, while, personally, I'm trying to implement some of these practices that can increase soil health. Mycorrhizal, fungi increase microbial activity in the soil, but we're combating all the negative aspects from pesticides and fertilizers. So for me, it's kind of how do we transition from those negative practices to increase soil health while still producing a product and getting good yields.
Yeah, for me, honestly, this soil health initiative went a long ways in addressing some of the concerns I had about research gaps. Our previous way of funding this, where we did, 1 to 3 year research projects on grower fields, and then we kicked out, I don't think was answering or doing us much good in this case. That being said, I do have concerns. First of all, the stuff all sounds good, but I need to see proof that it works. And I know what fumigation does. I know how to establish a stand with it. I need to see mileage out of the bios that can match this, and like Riley said, also limiting damage from our current practices, help with that. So that's kind of where I'm at on that.
Tom, Mark, Jerry, any thoughts on, you've summarized well what work has been done and laid out some things we still don't know, but what do you feel like are the most significant research gaps that we need to address going forward?
So, okay, good, it is, yeah. I do have an opinion, and I think this is very important. Again, coming from California, Jerry, you alluded to it, the transition away from conventional soil fumigation to something else is going to be paradigmatic in its shift, because it's not just the berries, it's everything else around it. Our vegetable industry depends on those fumigations. So to make the transition, if you want to call it a gap, I call it a chasm. It'll be enormous in its effect, but it needs to be done because, as I said in my own talk, that transition away from those fumigants is very much desired with people that have a lot of power. And so we need to figure it out, and we need to figure out the entire system at the same time. And that's what makes it so great to come up here and interact with my colleagues up here in Washington State. Matter of fact, we had a group come to us from Japan 3 weeks ago to tour a farm. You know, they're working with the Japanese Agriculture Ministry. We talked about fumigation. I'm figuring, hey, it's Japan. They're very advanced, very hardworking. So what are you doing? They're trying to get rid of chlorpicrin. They are in the same boat that we all are. And what was really nice to interact with those people is that now we can share what they're doing with them, and they can share with us what they're doing, because this is really a global shift that is happening. So thank you.
I'll add a little bit more as well. As we started talking about, there are all these sorts of ways that we can manage for overall improved soil health, organic amendments, cover crops, things like that. And they can have marginal influences. They're not going to replace fumigation, but they can have marginal influences to help us get there. But we need to look at these things in longer term and more holistically, because all of those options, and it's kind of like the paradigm shift you're talking about, Mark. There's also a paradigm shift in terms of, we're not just looking at, a linear reduce the pathogen, improve plant establishment growth. We're also improving soil organic matter, cation exchange capacity, reducing the need for fertilizer, maybe reducing the need for herbicides, maybe not, maybe reducing the need for fungicides as well as nematicides. So how do we need to do work on the economics of some of these things that we already have, and we know that we can start to use more. So we need to work on the economics of them, but also on how to, because we know that some of them, the economics are not there, but how can we start developing incentives, if you will, to offset the costs for those things? Yeah, as part of the economic calculus.
Just make a tiny comment onto that. And that is one of the things. If you're creating, because a lot of people see the elimination of fumigants as being a public good. So if you're creating a public good, then you can incentivize growers to do that by subsidizing that activity. Thanks for bringing that up.
That's a great point. Jerry, anything to add here?
I will
to
say fumigation has tended to be sort of, in other industries, it's one shot and that's what works. If we're moving away from fumigation, we're being forced that way. Many of the replacement options, the fungicides, some more organic options, for example, you can work with irrigation placement and perhaps reduce phytophthora root rot. You can use different mulches and perhaps reduce root rot. You can incorporate gypsum into the soil. Those tend to have a smaller effect. Ideally, fumigation would just knock everything back and you'd start from a relatively clean slate. But with all of the other non-fumigant options, it's going to take a lot of futzing around with it. And how do you get them to work in concert together? Because each one of those, like fungicides, gypsum, irrigation, each one of those is going to have probably a relatively small effect. And where our gaps are is we don't know how some of these soil-borne pathogens, particularly Phytophthora rubi, are going to respond to small little changes like incorporating gypsum, organic matter. We just don't have that data. There's more data available for verticillium from other crops, but for me, the knowledge gaps are how will Phytophthora respond to all of these changes.
Thank you. Yeah. And I heard a couple of you say, thinking about the entire system, thinking about it holistically and for the long term. So it seems like good opportunity for collaboration between soil scientists, plant physiologists, pathologists, nematologists, growers to really think about, and economists to really think about this holistically. I'm going to go a little bit out of order on our questions here, but we've talked about some options, but we haven't touched very much on inoculants and kind of, one of you mentioned there's a bajillion biologicals out on the market, which is true. Can you talk a little bit about maybe Riley and Kevin, what you're seeing, what you're interested in, and then for others, what we know about biostimulants or inoculants and what we still need to know?
I'm definitely interested in inoculants as a way to kind of combat the negative impacts on our soil from, like I mentioned before, synthetic fertilizers, pesticides. I've done a couple small trials using a couple different products, but at this point, I haven't really seen good positive effects. And kind of back to my original point from the previous question, you know, finding that kind of that roadmap, that transition. There's all these things that we can do as farmers to try to improve our soil health, but we're still combating the same practices that we use that kind of got us into this problem in the first place. So I mean, my personal opinion is that I'm not seeing these positive effects on the soil from these inoculants because I'm negating all of them with the same products I've been using that got me into the problem in the first place. So I'm glad we brought up the, you know, the incentives and like the public good aspect of kind of getting away from some of these products, because that's kind of what I meant by finding a roadmap for conventional growers, because, you know, we're using these products and soil amendments, things like that, that are essentially creating this self-fulfilling prophecy of us being stuck requiring synthetic fertilizers and pesticides. And we can't really get away from that unless we stop using them. At least that's what I'm seeing, you know. So there has to be some kind of economic incentive shift, because obviously commercial growers were doing this to make money, and you can't pay your land rent if you're not producing products, and you can't just let your land sit fallow for 10 years trying to improve soil health while not using fertilizers and pesticides. So we have to find a way to kind of make that jump.
I think I'd like to follow up on what Riley said too. We've done several different types of inoculants, biological and whatnot over the years. We run into one where we took the time, filled a tank, agitated it for a couple days, injected it directly in the soil. We got no results. Go back to talk to the salesman, and he goes, well, you guys sprayed fungicide, so you killed all the work you've done. Okay, one, we have a little bit of a gray mold problem up here, so we have to spray some for fungicides too. Maybe you should have told me that up front. I mean, and that kind of iterates what our experience has been. So 1 year we'll get great response out of some. We'll be like, wow, we think we found it. The next year we'll do the same treatment on a different block or follow up on that block, and we see no result or even negative results. So we're just not seeing consistency when we do this. And it's hard to justify spending the money. You know, you start looking at the costs of these, cost per acre gets pretty steep pretty fast. The one we've kind of stayed pretty steady on is we've done humics now for about the last 6-7 years on our ground. And we believe, and there again, it's all anecdotal, we are seeing some benefits out of humic products being added to our soils.
Jerry, what percent increase are you seeing by using those humics? What do you think? Like maybe a 10% gain?
I'm looking at more from the plant health, and what we're seeing is in both raspberries and blueberries, increased cane numbers and shoot growth in the blueberries. And then we're also seeing some help with drought and just plant health overall. As far as tonnage, I can't put a number to it.
Specifically to the topic of the biologicals, we did some work a number of years ago in tree fruit replant on mycorrhizal fungi, and we found that they work really well if you're going into fumigated soil. Again, getting back. So there's that working it around your system. Going into non-fumigated soil that was actually in sod for a year beforehand, it supported enough natural mycorrhizal populations that whether you inoculated or not didn't matter. And so that's a particular question, or the reason I'm making that point is it's interesting or whatever, but also it just points to, I think there is still lots of potential for biologicals for control of soil-borne diseases. However, they're going to be very, very case specific. And so it's going to take a lot more nuanced knowledge as you got to. And so again, it's a paradigm shift. It's like every time you think about doing one, you're going to have to do a little bit more research on, will this work on my pathogen in this soil, in this context as well?
Tom, that's very well said, because I've actually, at the request of grower, I started looking at seaweed extracts. I think some of you are familiar with these. And a colleague of mine left behind a whole book on seaweed extracts and went through it. And it's farm to farm, condition to condition. And I've worked with a lot of the biological fungicides, especially soil applied. And it's really dawned on me. And again, working with very smart people, USDA, UC, it's becoming very evident that we don't understand these things very well. There's probably some that are resistant to fungicides. What type of fungicide is? You need to know all that. What pH do we need? What level of organic matter do we need? Is it fumigated? I actually did one together with anaerobic soil disinfestation because you have that ecological shift. Does it do better there? And which one? And on top of that, we got like 100,000 of these fungicides that people are trying out, and their salespeople are very effective. So, man, it's huge. If you wanted to study a single biofungicide, you could make a career out of it. And maybe you would get some useful information for 10% of the growers. There is potential there, but figuring this thing out is huge. Anyway, that's my comment.
Jerry, comments to add?
I do. I think I will be much more pessimistic on biologicals. I have watched people put a lot of effort into biologicals for decades for pest management in the soil or for disease management in the soil. It is extremely difficult. I'm trying to think of a good analogy and I can't, but the reason you're seeing inconsistency is that each one of your fields has a very different microbial community than somebody else's field. It would be almost like the differences between Tokyo, Japan and Portland, Oregon. Yeah, there are some similarities and there are some major players in that community that are the same, but there are large differences. And we've done one study showing that a biological may work in somebody's field because the microbial composition is this way, but it may not work in somebody else's field because the microbial composition is completely different, and that biological doesn't play well with others in that system. We've also, as part of that study, you can see that what works one year may not work the next. And how do you get the timing right? And how do you get the plants colonized? Or there are just inconsistencies as well within the biological production. We messed around for years with one with Streptomyces lidicus, and the manufacturer would say, oh, the reason you're not getting anything is because you have chlorine in your water. Well, we used water without chlorine and it still didn't work. Turned out that the product was dead, and it took a while to figure that out. And there are just so many complexities in dealing with biologicals. I will say I usually don't see it work in soil communities. It is great, I think, what somebody said, where you start with the fumigated soil and you need to get a mycorrhizal fungus in there, or if you want to use it as sort of a fertilizer amendment, I think those work relatively well. But I'll give one last example from the nursery system. I've worked with nurseries that apply a lot of proprietary blends of biologicals to control Phytophthora root rot. And I work with nurseries that don't do any of that. There is no difference in the amount of disease between those who use biologicals for Phytophthora root rot and other soil-borne diseases and those who don't use it. There's just the same amount of Phytophthora root rot in each. So I'm going to be just blunt and pessimistic. I think biologicals are going to be a very hard row to hoe for soil-borne pathogens.
Just to add on to that, I think we have sort of our similar mind, but I will share you that what the California Department of Pesticide Regulation has, as of 4 years, created a separate department for evaluating biological fungicides. And what's problematic to us, and they actually came out and I talked to them, there was a group of us, that they're using lower efficacy thresholds for labeling. As you know, in California, you have to show efficacy before you can get a label for a fungicide or pesticide in California. But because they believe the environmental impacts of these are not beneficial, but they're less injurious to the surrounding environment. They're lowering the threshold for the efficacy requirement on these biological fungicides. This is very concerning to me, and I told her that because growers in California, if it's being sold, you believe that you have that good housekeeping stamp or whatever that says this works, but now they're looking at it a different way. And again, California is a huge market, so you're going to see really a flourishing of these biological fungicides. So more than ever, caveat emptor, consumer beware of what is going on with these things. And yes, we will continue to test, and I am certain, because it's always, and you know this, Jeremy too, is that, well, if you find one, it's going to be grand. It'll be really grand, but you got to do a lot of searching, I feel. Yeah.
Yeah, thank you for all those perspectives. Definitely, I'm in agreement. And I think that the microbiome and the interactions even between the indigenous microbes and organisms that are in the soil is very challenging to understand. And I think we have more and more tools to do that. But I think that's an important thing to keep looking at. We have about 10 minutes left, and I do want to leave time in case there's any audience questions. But I wanted to also just, we've talked about incentives and just ways that growers can be supported in adopting new and different practices. And Riley and Kevin, I wanted to just pitch to you, what are programs or incentives that, would be supportive and helpful to you in kind of thinking about transitioning adoption of different practices.
I mean, honestly, we need more research to show that, that there's some practices that are better than others for long-term soil health and reduction in harmful materials, that we apply to our soils and things like that. So, I mean, honestly, what it comes down to is going to be, financial incentives or subsidies to kind of cover that risk aspect. We collaborate and work on a number of research projects with people from WSU primarily. But there's always that risk or that issue in the back of our head is, is this going to harm our crop? Is this going to cost us, tens or hundreds of thousands of dollars to go along with this? So, I mean, ultimately it would have to be some kind of incentive, insurance program that, sure, we can try that on this 10-acre block, but there's going to have to be some kind of financial compensation for what we may lose to risk it.
Yeah, I think Riley summed up pretty well my thoughts too. Basically, I don't want to feel like I'm taking all the risk, putting my employer and my job at risk by going out on a limb. We need some support there until we get comfortable with the practices.
If I can add one thing, I mean, as a grower, we do take on some risk. I mean, obviously, I know Kevin's doing it too. We're doing some stuff on our own, but I mean, we haven't gone so far as extreme to be, no synthetic fertilizer, so to say, or we're going to not use fungicides because the risk there is just too much.
Hopefully more continued long-term research can help answer some of those questions and kind of guide what are appropriate solutions. We have a few minutes left, and I just wanted to see if there's any questions from the audience for the panelists. Yes. We have a couple up here in the front, if we can grab a microphone.
Yep, nope, I'm on it.
Thank you, Liz.
All right.
So are there any NCRS parameters that have been outlined at this point to help with subsidizing some of this effort at the grower level? Or is that something that needs to be considered?
Does anybody have an answer? I don't know.
Yeah, there's none that I'm aware of, but it's not an avenue I've looked at either. So we do most of our research in conjunction with the university and through the extension agency. So
I think it gets complicated because, from the standpoint of, for example, the USDA, they see subsidizing research as already a contribution to the growers to help them solve problems. This is a next step. This is almost now in the arena of politics, right? So it's a really good question. I think it's something that really needs to be discussed because as these transitions get so difficult, like you guys, both you said, Kevin and Riley, the grower shouldn't be bearing all that risk. It's tremendous. And so, but it is a public good. I mean, everybody agrees, you know, we need to move away from the fumigants. Well, then everybody can participate in that, right? Thank you.
Yeah, I will also mention, there's of course NRCS programs that help cover things like cover crop seed in different systems. Washington State Department of Ag is also launching it's called the STAR program. It was developed first in Illinois and then transitioned to Colorado, and we're launching it here in Washington. And it's very cropping system specific. So it's trying not to kind of paint a broad brush about, okay, everyone should be doing X, Y, and Z practice. It's really thinking about what are the resource concerns or the soil health concerns in red raspberry or in tree fruit or in grains, and what are the practices that are going to help improve those, and then kind of creating a STAR program based on the number of practices that grower has adopted that are appropriate to that system. So that's something to kind of keep an eye out for in the coming couple of years.
This question is slightly off topic, but bee crop or biomaker soil, has any of you guys worked with that, or what your thoughts are on have you heard of bee crop or biomaker soil test? Yes.
I have, and I've been sending samples to them for the last 2 years. And that's one of the primary markers, so to say, on whether or not some of these inoculants that I've been using have been working. And I really have seen no significant changes, you know, from their soil sample testing. They're also rather expensive. It's $200 a sample. So in some of these trials that I've been doing, you know, small plots, I'm usually just doing one spring, one fall, but it's, you know, $400 right there for each plot.
Any other questions? Oh, okay, we have one up front. Just gonna see.
Hi, has there been any research using like a competing edible fungus like a mushroom to outcompete fungi pests?
Well, I was just going to say that indirectly, we were talking a little bit ago about biological controls or biologicals, and that essentially all that research started from kind of that perspective. Maybe not necessarily edible fungi, but looking for fungi that will outcompete or even directly parasitize the pathogenic fungi. So yeah, so in a way, that's kind of what you're talking about, and so that's become a big business. Actually, is you know, research to try to identify these things, and but then the next step, as we were just discussing, to get them to actually work in the field to provide an economically measurable benefit, you know, to offset the cost. We're still working on that with soil-borne diseases.
You know, the one thing I'll say, these meetings are really great because it brings out into the public the challenges we face. You know, listen to your question here, the challenges we face in trying to find a biological fungicide. Because I mean, from a public policy standpoint, this sounds really, really good. It makes a lot of sense. It works in the lab, and then you take it out in the field, and then it gets really complicated. So having these, so all of us understanding where we stand on these right now is very important. Yeah.
On the last couple minutes I have, I just want to give each of our speakers 30 seconds to a minute to guys kind of think about, where do you hope that we are in 10 years? Where do you hope we are in terms of management, in terms of our knowledge, our research? You want to go ahead, Mark?
No fumigants, and we're at the same standpoint we are as far as yields and crop productivity. And man, that's a hard pull. But I'm an optimist. You got to deal with that. So that's mine.
I agree with what Mark just said, but we will have, how we'll get there is that we'll have more complex systems. We'll have more actual crop rotation happening with our perennials like between. Maybe not potato though. But these are the kinds of things that will be, the research will lead us to rotation crops, to alleyway cover crops, and to all sorts of things that will all incrementally help us to get there. But I think it is achievable within 10 years to have a system that will give us sustained yields comparable to our current fumigation plant, rip it out, fumigate, replant system.
I think, as a grower here, that sounds good. We want to be here in 10 years still farming is our first and foremost worry. And I think not only maintain yields, but we want to see increasing yields over the time. And I'm of the opinion that we're pretty knowledgeable about nutrients, crop nutrients. We're pretty knowledgeable about growing the crop, but the next step for yields will come out of this. It's probably going to be tailored by the field or by the farm, but I think this will play a role in getting us to the next level to get more yield, to hopefully be more economical going forward. And then, I think we're all farmers. We all love our land. So anything we can do that preserves it, builds it, and leaves it for the next generation. That's something we talk about on our farm. So, and I think Riley's on the same page.
Yeah, I mean, ultimately in the next, in 10 years, I hope our farm's still operating. I hope we are just more sustainable, meaning that we're reliant, I want to be less reliant on synthetic fertilizers. I'm hoping to have our whole farm kind of no-till by then. We've been doing some trials with, diverse runway cover crops, looking at different blends of plant species for that. And I'm hoping because of things like that we're just using a lot less pesticides and fertilizers. I will push back on Kevin just a little bit on the higher yields aspect, because I mean, at least in my opinion, it's not necessarily about more revenue, but just more profit for the farm. So I think we could get away with the same yields or even less yields if we can significantly reduce our costs by reducing these, synthetic fertilizers and pesticides. So I think there's a happy medium in there somewhere where we can, massively reduce inputs and rely more on the natural soil ecosystems and still make as much money. And, obviously if we're profitable, we'll continue to be in business.
Jerry, I'll give you the last word.
I would say I've got two things. One, I would like to see the community that supports this industry to continue to be as diverse and thrive as much as it has been. I know there's intense pressure to consolidate and to fold and not continue. So I would like to see the red raspberry industry continue to thrive with what we have. The pressures out there are intense. The other thing that I would like to see is in the future is better soil-borne disease control than you have now. I think in my presentation, I felt pretty grim about it. I don't think you're getting good soil-borne disease control now, particularly against Phytophthora rubi. And I'm hoping by combining some new ways of improving soil health and new ways of growing the crop that you can improve that.
Great. Well, I want to thank all of our speakers very much for their presentations and all of their comments and thoughts today. And thanks for being here.
So this was a great turnout and great presentations, which was made possible by our speakers. So Washi would like to thank each one of you with a Washington Soil Health Initiative hat. Jerry, I figured you didn't want yours, so I gave it to Molly. Hope you don't mind.
Oh, I'm okay.
Awesome. Thank you.
Awesome.
Yeah.
So thank you all so much. Just a reminder, if you signed in, you had to sign in for pesticide credits. So if you snuck in late, too bad. So check out for pesticide credits using the scanner. We will have 2 people. I know we will still have 2 people that will sign up I'm not that mean. We do have paper sign-ins too. Also sign out because we all know how technology works and it never does. So we would like the backup. Again, this is our trial session to test out the new technology, scan out, be patient with our interns as they help you with that. But also we have a paper version as well. Pink is WSDA. We do not have Oregon credits this year, and white is for anyone in British Columbia. All right, go eat.
Okay.
Bye, everybody.
Thank you.
Yeah. Yeah, that's good.
Guys. Make a floating one. Green boat, thank you. Okay. I wonder if it's messing up, just switch it to check-in mode, because we'll have a time code. We're doing both. Okay, we're worried. You don't want pesticide credits, you don't have to scan. You don't have to scan if you don't want pesticide credits. So like if you're not getting credits for this session. Yeah. If it's not working, I think you can switch it just going good. Okay, cool. I realized if it starts messing up, I think you can switch it to check-in mode and it'll still.